Okay, so to do 10.2 number 47, I need to figure out how to deal with decimals under the roots, right? Okay, so I don't really know how to square root decimals, right? But I do have some idea how to square root fractions. Okay, so maybe I should rewrite these as fractions. So what's 0.98 as a fraction? It's 98 over 100. I could do a little better than that, but maybe we'll just leave it. Okay, so I've got the square root of 98 over 100 plus twice, what's 0.75 as a fraction? 3/4, or 75 over 100.
Yeah.
Really, either way. I'm going to go with 3/4 because it's going to simplify my process a bit, and because I think most of you see that. How about 0.12?
12 over 100.
Yeah, 12 over 100, or maybe 6 over 50 if you happen to see it. Yeah, or
Well, 3 over 25.
some other kind of similar thing. How about 72? 0.72 is, yeah, I'll probably just do 72 over 100 because I don't know a better way right off the top of my head. Okay, so now when I'm square rooting fractions, how do I do that? Yeah, okay. I can square at the top and the bottom. What's convenient about that here? Yeah, a bunch of them have a common bottom, right? And also I know how to square root that bottom already. You guys see that? Okay, so this is going to be 7, the square root of 98 over
10.
Oh yeah, the square root of 100 is 10. Plus 2 root 3's over, oops, root 3's over 2. Right? Okay. Minus the square root of 12 over 10. Plus 5 times
Square root of 72 over 10.
square root of 72 over 10. Okay, now we're going to play some factoring games, right? To try to get these down as much as I can. Okay, so, which one of these is easiest to attack?
Well,
12.
12.
Oh, yeah. Okay, so I might want to look at 12 and think to myself, what's 12?
3 times 2 times 2.
It's 3 times 2 squared, right? 3 times 4, and I know how to take the square root of 4. How about, bummer, right? 98, 72, I'm going to have
72
to...
is 2 times 2 times 2 times 3 times 3.
Yeah, okay, let's figure out how you're getting that.
Divide by 2 twice, and then a third time, and then it's 9.
Okay, so I'm factor treeing, right? So 72 is twice
36.
36. 36 is
6 times 6.
6 times 6.
Which
And
is 3
6
and
is
2 and 3.
2 times 3. Okay, so 72 is 2 to the
Cubed.
cube,
3
3 squared. Right? I don't know how to square root that thing, right? But I do know how to square root a pair of the 2's and a pair of 3's, right? You guys see that? So I might rewrite this as twice 2 squared times 3 squared, right? And then this stuff I know how to deal with. The other thing I don't. Or maybe I should notice that it's twice something that I know how to square root here. You guys see that? Either way. So I might think to myself, 72 is 2 times 36.
98 is 2 times 49.
Oh yeah, okay, so I might play a similar game with 98, right? Find out that 98 is twice 49. Okay, so I can take this whole thing and rewrite as, so I've got 7,
7 root 2 over 10.
maybe like this for now. Okay, so I've got 7 times the square root of 2 times the square root of 49, which I'll replace in a second. How about that next guy?
It
2 root
stays
3
the
over
same.
Stays the same? Okay. And then we get minus the square root of 3 times the square root of 4 over 10 plus 5 times the square root of 2 times the square root of 36 over 10. Right? Okay, so then we go through and replace the bits we can. So I've got 7 times 7 root 2's over 10 plus
Common bottom for that too.
okay, so I could try to get it over the common bottom of 10, right? Or I could cancel the 2's.
Yeah.
Okay, see that? You get this choice here.
Or you could have just kept it under the common bottom of 10 to begin with. And
Yeah,
you
and-
had 3. It would have been
Which,
5 root 3 over 10. 2 times 5 root 3 over 10.
yeah, which thing is preferable here?
Probably get rid of the 2.
Well, I don't know. I actually don't know. It depends on how much stuff cancels later, right?
I would like to keep.
I'm going to do this because I'm cancel happy. You guys can do whatever you want. Okay, and then I got, how about this guy? What's that turn into?
2 square root of 3.
2 root 3's over 10. And this other guy is 30 root 2's over 10. Okay, done with that. All right, so which of these are like terms?
All of them except for root 3.
No.
Well, I mean, root 3 is 10 root 3 over 10.
Yeah, root 3 is 10 root 3 over 10. So which of these are like terms?
All of them.
The 2 square root of 2's and the 2 root 3's.
The ones with the square root of 2's, right, can get combined, and the ones with the square root of 3's can get combined. So here I have 10 root 3's over 10, and then 2 root 3's over 10 took off, so what am I left with? 8 root 3's over 10. And I have here, how many root 2's over 10?
49.
49, and over there I have
30.
30, so all told I have
79.
79 root 2's over 10. Okay, can I do any better than this?
By that term, I meant that it's all over 10.
Yeah, so I could combine them and put them over 10, all over 10, or don't do that.
You could simplify the 10 for the 8. if you
Yeah, I
wanted
could
to.
cancel a 2 here, right?
If you want to.
How did
So-
you get 8 from the 30 again? Or did you get
Yeah, how did you get like
10 minus that.
Oh, right, okay, gotcha.
Oh.
Same thing, okay.
I thought of 1 root 3 as 10 tenths of a root 3, right? And then subtracted 2 tenths of 1. Cool? All right, so at this point you get your option. You can either do this as 4 root 3's over 5 plus 79 root 2's over 10. Or you can do this as 8 root 3's plus 79 root 2's all over 10. Right, so either of those is an acceptable answer. This one needs something done with it to simplify. Okay, I don't care which way you go with that, but it does need something done with it to simplify. Cool? So I personally would go with this one, but that's just because I cancel out. The other one is also a reasonable option. Cool?